Hello there and welcome to Lower 6 Further Maths A-Level January Mock Exam Revision Sheet 3. Here we're working on question 2. Given that 1 plus 3i is the root of an equation z cubed plus 6z plus 20 equals 0, find the other two roots of the equation. Okay, so first what I'm going to do, the first of these two roots will be easy to find. If I know that 1 plus 3i is the root of a polynomial, then I know that 1 minus 3i is also a root of a real numbered polynomial. So from here what I can do is if I set z equal to 1 plus or minus 3i, what I'm going to do is reverse complete the square, get a quadratic and then divide this by that quadratic. So z minus 1 equals plus or minus 3i, square both sides. The minus 9 comes from I being squared to give you minus 1, and then plus or minus 3 being squared to give you the 9. So minus 1 times 9 gives you minus 9. And then expand the brackets, don't need that anymore. Z squared minus 2z plus 1, and plus the 9 onto the other side as well. You get plus 10 equals 0. So what I'm going to do now is I'm going to factorize, z cubed plus 6z plus 20 with z squared minus 2z plus 10. Now what do I need in my third bracket and my third root? Well, I'm going to need z times z to give me the z cubed. I'm then going to get minus 2z squared. So if I then put a plus 2 here, then that's going to give me plus 2z squared, which will cancel out any z squared. And you can see here the reason I've done that is because I have no z squareds in my polynomial expansion. Let's just make sure the other bits will work as well. So for the z, I'm going to get minus 2z times 2 here, that'd be minus 4z, and plus 10z, minus 4 add 10 will give me the plus 6z, good, and 10 times 2 is 20, so I'm going to get 20 at the back there as well, which is good. So this is how we factorize our polynomial up here. So therefore my three roots must be 1 plus 3i, I suppose that was given to us, 1 minus 3i, which was the next one I found, and then from this expression here, z must also equal minus 2. Okay, so those are the three roots of this polynomial. You can also check that on your calculator. If you go to menu, down to option A, so scroll your way down, option A you want, press enter, press polynomial, option number 2, click on a cubic polynomial, so degree 3, and type in your coefficients. Now with this one here, be careful, it's 1z cubed, 0 z squared, 6 on the x, and 20 here. There's no z's, it's x's, but it doesn't really matter. Press enter, but first before you do that, just make sure that shift and then setup, scroll down twice and go to equation/function, press enter on equation/function, so option 1 here, and then tick on complex numbers, so select option 1 here. If you didn't select this option here, you'll only get the minus 2 solution. You do want complex number solutions. Okay, so go back there, press enter, you get minus 2 as your first solution, press enter again, second solution, 1 plus root 3i, and 1 minus 3i is there as well. Okay, good. So it's quite handy to have that option available to you. Okay, part B is show all of these three roots on an Argand diagram. So minus 2 is going to be back here. 1 plus 3i is up here. And 1 minus 3i is down here. Okay, so from here, part C asks for us to show that the three vertices form a right-angled triangle. So this triangle here is right-angled. I assume the right angle is here. So what I'm going to do is work out all of these distances using the formula for the distance between two coordinates, and then hopefully Pythagoras' theorem will work on this formula. So from 1 plus 3i to 1 minus 3i, the difference here is just going to be a distance of 6. So from here to here the distance is 6. From 1 plus 3i, it's going to be a formula of, so it's going to minus 2, so we're going left by 3 and down by 3, so it'd be 3 squared add 3 squared, which would be 3 root 2. Exactly the same thing will happen for 1 minus 3i to minus 2. You're going to be going left by 3 and up by 3. So that's going to be 3 squared plus 3 squared, which is 3 root 2. And then just check this follows Pythagoras, and you need to include some clue as to how you're working this out. So Pythagoras check, let's do 3 root 2 squared add 3 root 2 squared, and that will give you the square root of, that would be 9 times by 2, that's 18, add another 18, that will give you 18 plus 18 is 36, the square root of 36 is 6, which is exactly what we wanted for our longest side on our right angle triangle there. So that's how you prove that. 6 marks.